Hello all, today we're going to be learning about how to determine whether or not a table is proportional or not proportional. So that is our key concept for today. And we want to know, well, what is a proportional relationship to begin with? From our Math Antics video, we did get some type of definition. However, we do want to kind of expand on that. So we have two quantities, x and y, have a proportional relationship if y is always a constant multiple of x. And a relationship is proportional if it can be described with equivalent ratios or fractions, whichever you want to think of. Both will do. Our process is pretty simple. There's only really two steps to check. One is to create ratios in the form of y over x, and we'll talk about y and x in a moment, from your table. And you want to check to see if all the ratios are equivalent to one another by writing the ratios in simplest form. The good thing about this is that, we're going to be able to use calculators. Once you simplified all those ratios, if they are equivalent, meaning they have the same value, then it's proportional. If they are all not equivalent, then it's not proportional. And it's really that easy.
Hey guys, Miss Buhauen here. So I'm taking you today on my gym workout, and we're going to check out some proportional relationships.
Example number 1 is the warm-up. To begin her workout, Miss Buhauen starts with a mile run. Her times are listed below in the table. The question is the distance ran proportional to the amount of time it took? Explain. So, to begin, at 0 minutes, I ran 0 miles. Next up, in 3 minutes, I ran 0.25 miles. In 6 minutes, I ran 0.5 miles. In 9 minutes, I ran 0.75 miles. In 12 minutes, I ran 1 mile, and as you can see, I kept going. So in 15 minutes, I ran 1.25 miles. So now if we think back to our process, how we determine whether or not this table is proportional is we do it through finding equivalent ratios to decide whether or not these ratios are equivalent. So first, we need to make ratios. The first one is not going to do anything for us because, it's 0, 0. And if we put 0 over 0, we're going to get 0. So we're actually not going to start with these because, again, not going to do anything. We're actually going to start here. So if you notice, our ratio tells us it's going to be distance over time. And that's because the second number is going to be our y, and the first number is going to be our x. And if you remember in the process, we're going to write the ratios as ratios of y over x. So let's just get into it. So for the first one, we have our y being 0.25 over 3. Our second one, we have 0.5 over 6. Third, not 9, 0.75 over 9. Then we have 1 over 12. Next, we have 1.25 over 15. And again, I'm lucky, you're lucky. We're just going to use our calculators to divide these up. And remember, when we're dividing, we use that super awesome fast food California restaurant, in and out. So go ahead, pause the video, check it out, go ahead and divide these. The first number, the top number, you would type in your calculator first. The second number would go second. So this number divided by this number. Try it out. So I use my calculator to divide these ratios, and remember, when I am dividing these ratios, what I'm doing is I am looking to see if they are all equivalent. And again, by equivalent, that they look different, and they sure do all look different. I'm checking to see whether or not they have the same value. So when I'm dividing, I'm checking to see whether they have the same value. For this first one, I actually got this crazy decimal, 0.083, and that 3 was going on forever. We call that a repeating decimal. And I don't want to write that all because it's way too much. So I'm just going to go ahead and round it to the nearest hundredth. So instead of 0.083 repeating, I'm going to write that is 0.08. Actually, that's not there because remember that first one was 0. It goes here, 0.08. For this next one, I got 0.08. After that, 0.08. And of course, 0.08. And the last one I did check it, I got 0.08. So you should notice something special about all of these numbers here. With the exception of the first one, because again, we're not worried about that. You're going to notice that they're actually all the same number. And if they are all the same number, it has the same value. And if ratios have the same value but they look different, that means that they are equivalent. And in this case, if they are equivalent, then it is a proportional relationship. Time for the writing because you guys got space for it. So here we have, for the table above, the relationship is proportional. And I know this because you should be writing something along the lines of the ratios, ratios of y over x are equivalent. Yours is going to look a lot nicer than mine because you're going to put your own spin on it. And please complete sentences. Example number 2. Continuing her cardio workout, Miss Puhan moves on to the Stairmaster. The times are pictured below, and the question is the number of floors climbed proportional to the amount of time that has passed, and do explain. Now, you might be wondering, well, what is a Stairmaster? I do add a couple of videos to show you. And this is what it does. Alright, I did my very best to take a picture while I was doing this workout of the times with the floors, and they are pictured on the side. So the first one, it was 4 minutes, and at those 4 minutes, I climbed 13 floors. At 12 minutes, I had climbed 46 floors. At 15 minutes, I climbed 58 floors. And the very last part, at 18 minutes, well, just about 18 minutes, I had climbed 69 floors. So we want to tell whether or not this table of time versus numbers of floors climbed, if this does represent a proportional relationship. Alright, so I gave myself a little working room here. So again, we're going to go ahead and start off by first putting our information that was given in our tables into ratios. And again, I'm going to write them in the form of y over x. So the first one, my y is 13 over 4. The second one, I have 46 over 12. Third, I have 58 over 15. And lastly, I have 69 over 18. From here, there are fractions that you can simplify. Like we can simplify, actually, this one here, both simplify by 2. So I could simplify that one. But I would say just use your calculator to divide them out and see whether or not your values are the same. So I'm going to go ahead and take out my calculator. And again, when we are using these, when we are dividing and using our calculator, we want to use in and out. So if we were drawing this out, 13 would go inside, 4 would go outside. And when we divide those, the top number, again, goes in your calculator first, divided by the bottom number would go second. So if I divide those, let me go ahead and do that. 13 divided by 4, I get, which you should have got, 3.25 for the first one. So the value of that fraction is 3.25. If I do the same thing for the second one, 46 divided by 12, I get 3.8, there's that number again, 3.8333333 repeating, and again, I'm just going to go ahead and round it. So that simplifies, or the value of 46 over 12 is 3.83. Right there, I already can tell one thing. Do you see it? Remember, the definition of proportionality is that our ratios are equivalent. Are these two ratios equivalent? Well, they look different, but do they have the same value? No. This one is 3.25. This one is 3.83. And right there, I don't have to keep going. I already know that this is not a proportional relationship because these two ratios are not equivalent. So honestly, I'm done. But since I'm here, since you're here, I'm going to go ahead and finish this up. So for the next one, I get 3.8 about 7. That's that fraction's value. And then the last one, 69 divided by 18, I get the 3.83. So the crazy thing is, if you guys notice, or notice with me, that these two numbers are the same, but it still doesn't make a proportional relationship. For it to be a proportional relationship, all of the numbers have to be the same, not just two. So this is not a proportional relationship. All right, we're done. Let's recap it. Example number 1 was a proportional relationship. And how we found that out was we took our data from our table, we put it into ratios of the form y over x, and we simplified those ratios by dividing. When we did, we noticed that all of those ratios did give us the same value, and therefore they are proportional. In example number 2, however, when we did the same process, we took our data, we put it into ratios of the form y over x. We noticed that even though 2 of them had the same value, when we compared all of them, they did not all have the same value. And if in your ratios you don't all have the same value, they are not equivalent, therefore it is not proportional. So let me go ahead and leave you with just this closing remark.
Alright, you guys, that's it. I got my cardio in, got my weightlifting in. Hope you enjoyed the video. You know, where does this math teacher go after her workout to fuel up?
Alright, it's your turn. With your groups, you're going to go ahead and determine whether or not these 3 tables, if they do represent a proportional relationship. You'll go over the answers with your teachers.